In the tutorial on percent yield, we learned that what is produced in theory and what is actually produced in a chemical reaction are two different things. In this problem here, we are asked for the percent yield. And so, but we are told that 102 grams of the methanol is produced. Now, really important to make the distinction that the 102 grams is referring to what is actually produced as a result of the chemical process that isn't completely efficient and starts with 20 grams of hydrogen. And so what we need to figure out in order to find the percent yield is the theoretical yield. So what should be produced in theory if the process is 100% efficient. And so really, you know what, I wrote down the given and the requireds here, but to organize stoichiometry problems, as you've seen before, I do like to just start with the chemical equation, the balanced chemical equation, and then take all the information that is given, so the fact that we have 20 grams, and that we know that we have lots of carbon dioxide, or it's the excess reagent, and I like to use the chemical equation to organize that, as well as what we are trying to find, which is the mass of methanol that should be produced in theory. The other pieces of information that I included that were relevant to solving this problem are the molar masses of the hydrogen and the methanol. So the thing that we have mass data for and the thing that we're trying to find mass data for. And so just like any stoichiometry problem, and specifically one that doesn't involve a limiting reagent, this is the approach we're going to take. So first we're going to take the mass of hydrogen and find the number of moles, use a mole ratio to connect the number of moles of hydrogen to the number of moles of methanol, and then convert the number of moles of methanol to a methanol mass using the molar mass of methanol. The final step, of course, is then to take the information that was given about the actual amount of methanol produced and compare it to the theoretical amount produced using the percent yield. And so, as per previous tutorials in stoichiometry, I've taken the same approach in laying it out. So the first step here, we're simply finding the number of moles of hydrogen. The second step, we're using the mole ratio, and of course on this side of the mole ratio is what I call the known ratio. So for every 1 mole of methanol, we have 3 moles of hydrogen being produced. That's what's shown here. And on this side of the ratio, we have what I call the unknown ratio, where we have our unknown and then the piece of information that we were given and converted to moles. So we converted the 20 grams of hydrogen to moles, and so we have the amount of hydrogen in moles here. And now we quite simply solve for x, and we find the number of moles of methanol. And again, just note in steps 1 and 2, I have underlined the number that is the last significant digit in those values that I've calculated, but I'm carrying more digits through. And typically, again, I like to carry at least 4 decimal places, if not more, depending on the number of significant digits. But quite often 4 will get the job done. So we take the number of moles of methanol and we multiply it by the molar mass of methanol to find the mass of methanol. And in doing that, we get a value that actually looks pretty close to our actual amount of 102 grams. And the final step here is to find the percent yield, so actual divided by theoretical multiplied by 100, and we get 96.4%. Now, as a check, I say reality, 96.4% is a reasonable answer. If you had 9,604%, then you maybe got a problem. Then you want to take a look at your calculations if there was a silly mistake made along the way, or maybe you have to look at your overall approach and modify it or change it. Also, the theoretical and actual values are somewhat close. So the 105 grams is pretty close to the 102 grams, and so you know that we're probably in the right ballpark here. If the theoretical amount is hundreds of times bigger than the actual amount, or hundreds of times smaller than the actual amount, then you know that probably this answer isn't correct. Again, that's not for certain, but you would at the very least, want to check through your calculation and make sure that you've done everything correctly. So we see here that percent yield calculations are essentially taking a stoichiometry approach to solving a problem, coming up with, in this case, the theoretical yield, and using the information that is given, the actual yield, to find the percent yield. And not all problems will be the same, obviously, but all problems will involve, in some shape or form, those three things: the percent yield, the actual yield, and the theoretical yield.